Hello, we are back again. I'm Eliska from Oranje, and we are going to look at electrostatics today. So I brought a few questions for you, but before we look at questions, I just want to review a couple of important points before we start. First of all, there are two equations that are very important when we do electrostatics. The first one, and this you will find on your information sheet at the end of your question paper in the end exam. The first one is F, and the second one is to calculate E. Those two. You must know the difference. So let's quickly write them down. The first one is Coulomb's law. And it says, I'm going to read it to you in words, and then as I read the words, I'm going to write the equation, and you'll see where it comes from. Coulomb's law says, the magnitude of the electrostatic force, so we write force, so the magnitude of the force exerted by one point charge, Q1, on another point charge, Q2, is directly proportional, so we write directly proportional to the product of the magnitude of the two charges. So the product means we're going to multiply them, and we're going to multiply the magnitude of charge 1 and the magnitude of charge 2, and inversely proportional, which means we're going to write it below the line, to the square of the distance r between them. So that's where Coulomb's law is coming from. Now, in mathematics, when we want to turn the proportional sign, directly proportional, into an equal sign, we can turn it into equal, but then we have to add a constant on the right hand side. So we put K, Q1, Q2 over R squared. And this constant was calculated for you by Mr. Coulomb, and it is also found on the information sheet. You will find it there. Coulomb's constant, okay, 9,0 times 10 to the power 9 Newton meter squared per Coulomb squared. So please look at the information sheet when you need that constant. Then other information you might need is the fundamental charge on an electron, and that you'll also find on the information sheet. There it is, charge on electron, E minus 1,6 times 10 to the power minus 19 Coulomb. And those are the two important constants, and then these two expressions we're going to use here. This one for force, electrostatic force, and this one for electric field. Alright, so let's jump into a question. The first question that I brought for you, we're going to do a couple of multiple choice questions because they will teach you the fundamental things that you need to know about electrostatics. So the first one we're going to do is a positively charged metal sphere, X. So as you read this question, you must please draw a picture because it's a lot of words and you're not going to be able to interpret all of this and remember all of it. So draw a picture and write the information as you go along. A positively charged metal sphere X. So we draw it. There it is. It's called X, and we know it is charged positively. It has more protons than electrons. On an insulated stand is brought into contact with an identical neutral. So it's same size, it's identical. It's sphere Y, and we know that the charge is neutral, so there's no charge on it. 0 Coulomb, and this one is a positive Coulomb. Even though it's 0, that just means that the protons are equal to the electrons. It doesn't mean that there's no protons or electrons. Protons equal electrons on this one, The positively charged one has more protons than electrons. And remember, the only one that can be transferred is electrons. We can never transfer protons. Alright, so let's read the question further. The two spheres are then separated. So they make contact and then we separate them. Which one of the following describes the charge on each sphere as they have been separated? So what's going to happen when these two spheres touch? This one is 0, this one is positively charged. So I hope that you guys agree with me that this one, sphere Y, is more negative than sphere X. Why do I say that? This sphere Y has more negatively charged electrons than sphere X because it's 0, so it's more negative. This one is positive, so it's more positive than 0 because you get the positive, then the 0, then the negative. So if I'm 0, I'm more to the negative side than the positive. So when these two touch, electrons will be transferred from Y to X. So this one will become more negative but still not 0, and the 0 will become more positive. This is it's kind of a difficult concept to understand, but I hope you guys get what I'm saying. So now they ask you, what will the charge be on both of these? This one was 0. It lost some of its negative electrons, so it will become positive. This one was already positive. It gained some electrons from this one, but still not enough to even make it 0. So they will both be positive. And then you go and see where's the answer. There, B, positive, positive. This is one of the harder ones. As we go along, you will see that this is not a very hard topic that we're talking about. Alright, let's look at number 2. Number 2 says, a negatively charged plastic comb. So we go and we draw a comb. We need a picture. We need a picture, otherwise we won't be able to understand these questions. A negatively charged plastic comb is brought close to, but does not touch. It doesn't touch a small piece of paper. So there's your paper. It's a small piece of paper. And the comb was charged, a negatively charged plastic comb. So this one was charged negatively. Is brought close to but does not touch a small piece of paper. If the comb and the paper are now attracted to each other, so they attract each other, which means, if you remember the charges, attracts, negative and positive charges attract each other, negative and neutral attract each other, and positive and neutral attract each other. Okay, so charges that attract each other, if you can, I don't know, if you don't know this, and you must write it down because this is very important. Attracting is negative and positive charges, negative and neutral, or positive and neutral. Charges that repel each other, positive and positive, negative and negative. These will repel each other, those will attract each other. So I'll quickly write that down, and then we go back to the problem. So the problem says the comb is charged negatively. We don't know the charge of the paper, but we know that they attract each other. They are attracted to each other. So the original charge on the paper, what must the original charge on the paper be in order to be attracted? So if this one's negative, the only two options that will attract is negative and positive and negative and neutral. So you must go and look for an answer that says it can be either positive or neutral, because the comb is already negative. The comb is negative, so the paper must then be either positive or neutral. And let's see if we have an option like that. We have number D, either positive or neutral. There we go, either positive or neutral. And that is number D. That's number 2. Right, this was number 1. Let's move on to number 3. Number 3 is a very, very important question, because you see it in every matric exam. If you've worked out past papers, you should have seen this one already. The sketch below shows two identical small metal spheres, A and B. So they're equal in size, but they have different charges, Q and 2Q. The magnitude Q and 2Q respectively. The distance between the centers of the two spheres is R. Alright, so there we go. We have R. Now the question. Sphere A exerts a force of magnitude F on sphere B. We know that A has a force of F on B. What is the magnitude of the force that sphere B exerts on sphere A? Now you're going to study this one and you're going to know this one. Remember Newton's third law? Whenever an object exerts a force on another, that object exerts the same force in magnitude, just in a different direction on object A. So this rule can be followed here, Newton 3. Newton 3 says the magnitude of the force of B on A will also be F, but in a different direction. So actually it should be negative F, but they don't ask for the direction. They only ask what is the magnitude. So the magnitude will also be F because of Newton's third law. I'm going to give you a minute to write this down. And it's so important to read the question well, because they didn't ask for, is it attractive, is it repelling, what is it? They asked the magnitude. The magnitude. Okay, let's move on to question 4. Once again, very important question for your final exam. You should be seeing one similar to this in the exam. Two identical metal spheres on insulated stands carry equal charges, so we draw them. Two identical small metal spheres on stand, so we can draw the stand, carry equal charges and are distance d apart from each other. So let me just get another pen. Okay, so the distance, oh, this one doesn't work either. Let's try the pen. Okay, so they have equal charges and they are a distance d from each other. So if we write the equation from Coulomb's law, if you want to know the magnitude of the force, it will be F equals K Q1 Q2 over R squared. Now the question is, the spheres are now placed a distance half d apart. So what are we doing? We're halving the distance, dividing the distance by 2. So now in our new situation, these spheres are a distance of half d apart from each other. They still carry charge Q and Q, but the distance has been halved. So what effect does this change in distance have on Coulomb's law, the expression that we have here? So let's go and substitute. F equals, okay, Q1, Q2, still the same charge, so nothing's different there, Q1, Q2, but now the distance R has been halved. So see what happens when we put in a bracket, still with the square, we put half an R. We substitute into R. It's now half an R. What happens when we simplify this? We get F equals K Q1 Q2, no change there. But on the bottom, we get 1/2 squared. Now, if you're not sure what the value of 1/2 squared is, you go and type it into your calculator. It will give you the answer to be 1/4. R squared stays R squared. Now, from the original expression to our final answer, what happened to this value? We still have K Q1 Q2, K Q1 Q2. But look below the line. We have an R squared. There it is. We still have the R squared. But what happens to the value of this whole thing? It is divided by a quarter. So if we divide by a quarter, we're actually multiplying by 4. Now, if you didn't know that, just imagine taking any value, say 8 divided by 2. 8 divided by 2 is 4. Now, what happens if you divide 8 by a smaller number? Say we divide 8 by a smaller number. We divide it by 1. What happens to my answer? My answer gets bigger. So this is a concept that's very important that you must understand. We're dividing by something that's 4 times smaller than the original expression. The original expression didn't have that 1/4 here. Now we're dividing by 1/4. So our answer becomes 4 times bigger. So let's go and see. We have an option. We have the option of, alright, we're going to do a couple more of these because it's a very important concept that you must get before you go and write your exam. It's going to be in there, definitely going to be one of the questions. Okay, so we have another one here that's almost the same, but let's do it again. I'm going to ask you to do this one by yourself. It's similar to number 4. It's just worded a little bit differently. So let's see if you guys can do it by yourself. I'm going to read through the question with you, and then you're going to see if you can do it by yourself. Number 5. Let's close up number 4. Number 4 is closed, so we are going to look at number 5. The question of number 5, wait, let me just fix this. That. There we go. Alright. The question of number 5 says, the centers of 2 identical metal spheres, and they drew a picture for you, are a distance r apart. They carry charges of Q1 and Q2 respectively. So they have identical charges as shown in the diagram below. Each sphere exerts an electrostatic force of magnitude F on the other. Okay? So we know, remember, F equals K Q1 Q2 over R squared. Now, that's your original expression. Now they're going to change this. The distance between the charges is now halved. We're cutting the distance between these two in half. And the charge on Q1 is doubled. So you must remember there are two things happening now. R is being halved and Q1 is being doubled. The magnitude of the new force that the one sphere exerts on the other is, and you must pick one of these. I'm going to leave you guys for 2 minutes. See if, and you must write an equation so you can see where this comes from. Don't just guess. Alright, I hope it went well. You must please email me feedback so I know if you guys understand, if I'm going too fast, if I'm going too slow. Please let me know. Okay, so let's see how this one works. Let's write the original expression again. F equals K Q1 Q2 over R squared. And that's the original one, and that's equal to F. They told us that. Now we must change this one. So what's going to change? First of all, they said half the distance. So below the line, we're going to put half R squared. But now, what happened to the top? Q1 was doubled. So we have 2 times Q1, but Q2 just stayed the same. Q2 didn't change. So that's how the expression changed now. Okay? So what is the final change in F then? Let's see what happens. Let's take that 2 and we go and put it in front so we get the original expression out. 2K Q1 Q2. I didn't change anything, I just put the 2 in front. Alright, and below the line, remember what is 1/2 squared? It is 1 over 4 R squared. Now, if you look at this expression, where is our original one? K Q1 Q2 over R squared. Do you see if the one I'm circling in red here? KQ1 Q2 over R squared. That's our original expression. But now what happened to this value? It is multiplied by 2 over 1/4. Now if you type this into your calculator, you'll see that it equals 8. 2 divided by 1/4 is 2 multiplied by 4, and this is equal to 8. Okay? So this value, the original expression, is multiplied by 8. So the force that's exerted becomes 8 times more. And let's see if there's an option that's been given that says 8F, and there it is, number D. Okay. So when the distance is halved, this causes the F to become 4 times more. But now also Q1 is doubled. So now it becomes 8 times more. So it increases by a factor of 8. Alright. This was number 5. For the first hour, we're only going to do multiple choice. It's very important that you understand these types of questions for multiple choice. The next one I brought for you, we're going to do number 8 and number 9. It's very important that you guys have these documents. It's been distributed to the school, so if you don't have it, please let us know so we can get it to you. It has the memo and everything with it, so there's no reason for you guys not to have access to these revision documents. Alright, so let's look at number 8. A charged object exerts an electrostatic force on another charged object. Okay, so let's draw the two objects. Let's make them spheres. Two objects. A charged object exerts an electrostatic force on another charged object. Which one of the following could cause the force to be halved? So once again we have F equals K Q1 Q2 over R squared. Now we want to know, what do we have to do with these two charges in order to get F to be half of the original expression? So that's our original. Let's go and look at the options. Number A says the charge on one object is removed. This is not going to cause it to half because one of these are going to go to 0 then. If this one goes to 0, then your answer is 0. So that's not going to work. Number B says the charge on one of the objects is doubled. Remember, what do we want to know? Which one of these would cause the force to be halved? We want F to become half an F. So what happens when we do number B? Number B says the charge on one of the objects is doubled. So let's take the one object and we double the charge. We put a 2 in front of it. Then we get K times 2Q1 Q2 over R squared. It's equal to F. Take the 2 to the front. F equals 2K Q1 Q2 over R squared. What happens to our answer? It gets 2 times bigger. It becomes more. It becomes doubled. Is that what we wanted? No, we want it to be halved. So it's not B. Not A, not B. Let's look at C. The charge of one of the objects is halved. I have an idea this one is going to be the correct one. Let's see what happens. The charge on one of the objects is halved. Alright, our original expression, K Q1 Q2 over R squared. What is going to happen if we halve one of these charges? Let's see. F equals K. Now we're going to halve Q1 times 1/2 Q1 Q2 over R squared. Take the half to the front. F equals 1/2 K Q1 Q2 over R squared. What happens to the force? It's going to be 1/2 of the original expression that didn't have that 1/2. So our answer is going to be 1/2 of the original one. Is that what we wanted? Yes, it was. Which one of the following could cause the force to be halved? So our answer is C. What happens if the charge on both objects is halved? Let's see what happens then. If we have both charges halved, F equals K, then we have times 1/2 Q1. But now we have to half Q2 as well. 1/2 Q2 over R squared. Now let's take both these halves to the front of the expression. F equals, what is 1/2 times 1/2? It is 1/4. 1/4 K Q1 Q2 over R squared. Now what happened to our original answer? There's our original KQ1 Q2 over R squared. But what happened to it now? It was multiplied by 1/4. So this F is going to become 4 times smaller. And we don't want 4 times smaller. We want it halved. So it is not D. I hope you guys are catching my drift here. It's the third one of these that we're doing. So it should be coming naturally to you guys now. Alright, let's move on to question 9. Question 9 is a little bit trickier than the rest, but not too much. Before we do number 9, I just want to do a quick review of what's happening in number 9. When we have two charges, say we have a charge that is +4 and we have a charge that is -2. A +4 and a -2. And we touch these two spheres. They touch. Electrons are going to be transferred from the more negative one to the more positive one. And when is it going to stop? It's going to stop when they both have equal charges. It's very, very, very important that you know this. I'm going to say it again. When we have two charged objects and we touch them, charge is going to move from the more negative one to the positive one, and it's going to stop when they both have the same charge. Okay, what happens if we have two negative charges? Let's do one with -8 and one with -4. We can make this, remember the unit for charge is coulomb. If we make it -8 and -4, where is charge going to move from? Let's make this one A and B. From B to A or from A to B? Quickly decide for yourself. Which one is more negative? I hope you all agree with me that it's number B. B is -8, so it's more negative. A is -4, so it's less negative. It's more positive. It's still negative, but it's more positive than B. So it's important that you guys see that charge will be transferred from the more negative to the more positive. This one is going to become less negative. This one is going to become more negative. What is the? Do you guys know the reason for this? It's because the only charge that can move, the only one between neutrons, protons, and electrons that can move and be transferred is electrons. We can't transfer protons or neutrons, so we can only transfer negative charge in the form of electrons. Okay. So how much charge will be transferred in this example here on top? Let's see, if 1 coulomb charge is transferred from B to A, B becomes -1 and A becomes +3. We're not equal yet. So let's transfer another one. From -1, if it loses one more negative, it goes to 0. This one gains a negative, plus 2. We're not equal yet. We have a 0 and a plus 2. So we give one more negative away. Remember, when you give a negative away, you become more positive. So this one becomes plus 1 then. And if this one gains a negative, it becomes plus 1. And we have the same charge of plus 1. But there's a very easy way to get to that. You don't have to do it steps-wise like this. All we can do is, we add these two original charges. Okay, so we add them together. Plus 4 plus minus 2. And we divide them by 2. So you're actually getting the average charge between the two. So the new charge will be plus 4 plus minus 2. That will be plus 2. Divided by 2 equals plus 1. And that's exactly what we said when we did it step by step. Plus 1 coulomb. So if they ever ask you what the new charge is when two charged objects touch each other, and they ask the new charge, you add the two charges, you divide by 2, and you get your answer of the new charge. Let's see what happens to the bottom one. We have a minus 4 and a minus 8. You add the 2 up. Minus 4 plus minus 8. You divide by 2. Minus 4 plus minus 8 equals minus 12. If you're not sure about this, please use your calculator. Even if you're sure about it, use your calculator and check it. Minus 4 plus minus 8 equals minus 12. Divided by 2 equals minus 6. So after they touched, we will have two spheres, one minus 6 coulomb, the other one minus 6 coulomb. And now they have the same charge, and what will happen now? Now they're going to repel each other. Okay, so now that we have a little bit of background about that, let's go and look at question 9. Two small identical metal spheres on insulated stands carry charges of minus q and plus 3q. So let's draw them. We have two identical charged objects. One carries a charge of minus q, carries a charge of plus 3q. Okay. When the centers of the spheres are separated by a certain distance, d, the one exerts an electrostatic force of magnitude F on the other. Okay, so they have a force of F on each other. Now we change this. The two spheres are now made to touch each other and are then brought back to the same distance as before. Now they ask the new magnitude of the force exerted on each other. So I hope you guys agree that once we touch these two objects, charge will be transferred from the more negative one to the more positive one. So let's say which one of these two is the more negative one of the two. And I hope you guys agree. Let's do number A and number B. Let's see which one is more negative. A, because it's minus q. B is more positive because it's plus 3q. So what will the new charge be if they touch each other? And what did we just say? How do we calculate the new charge when two objects touch each other? We add the two charges and we divide by 2. So let's do this with this example. So we have minus q plus 3q. So we add the two charges together and we divide by 2. Minus q plus 3q, and I hope you agree that that is 2q, divided by 2. 2 divided by 2 is 1. So the new charge on both of these objects will be plus 1q. They will be plus 1q. So the new charge will be plus 1q. Now how will that change the force that was exerted initially? Let's quickly look. Initially, in our first expression, before the two objects touched, we had F equals, minus q times 3q all over r squared. Now we don't have these two charges anymore. We don't have the minus q and the 3q anymore. We have changed that now because we've touched the two objects and both now have a charge of plus q. So let's go and substitute that. F equals plus q over r squared, because both have the same charge now of plus q. So how will these two forces compare? What happened to the magnitude of the first charge? Do you guys see that the magnitude of the first charge stayed the same? This one was just negative and this one was positive, but they were both 1q. What happened to the magnitude of charge 2? Charge 2 previously was 3q, now it is 1q. So the charge was divided by 3. Q2 was divided by 3 when they touched. So what will happen to F? F will also be 1/3 of the original charge. And let's see if we have an option for 1/3. And it is number B. I'm quickly going to review this one again because it's a lot to take in. Let's quickly review. Initially we had A and B, charges minus q and plus 3q. When they were a distance d from each other, they exerted a force with magnitude F on each other. Now we change the situation. We touch the two spheres. What is the new charge after the transfer? Charge is going to be transferred from the more negative one to the more positive one. So we add the two together, minus q plus 3q divided by 2. That's what our rule says. So minus q plus 3q equals 2q divided by 2. 2 divided by 2 equals 1. So our new charge on both these objects will be plus 1q. Now let's go substitute the original values in expression 1. The original values, minus q plus 3q over r squared. Nothing happened to the distance because they said after they touched, they put it back to where they were. So r stays the same distance. What happens in the second expression after they touched? They both now have charges of plus 1q. So we substitute plus 1q and plus 1q and the distance stayed the same. Now how does it compare? How does expression 1 and expression 2 compare? Expression 1, first q had a value of 1q. Second one, first q has a value of 1q. No change there. No change in magnitude there. 1q, 1q. What is the change in magnitude of q2? Initially it was 3q. After they touched, it became 1q. What happened to it? It became 3 times smaller. And if you multiply by something 3 times smaller, your answer becomes 3 times smaller. And that is why we said 1/3 F. Alright, let's move on. The next example that I brought for you is a very easy one. And it's just a rule that you must remember. Let's look at number 14. The diagram below doesn't us anymore. We're now busy with electric field. Electric field. E equals KQ over R squared. Okay? So the question